Hello, everyone, and welcome to the Section 3.3 homework review. This is our last meeting for Unit 3. I know you've all tried the homework, so let's get started in going over it. Number 1, use the compound interest formula to find the unknown value. Round your response to the nearest cent. So we're given P is 1500, R is 0.035, T is 3 years, and N is 4. We're asked to find A, so we write out our formula, and we plug in what we know. 1500 for P, 0.035 for R, 4 for N in both places, and 3 for T. Our first steps are multiplying the exponent together. 4 times 3 gives us an exponent of 12. We also must divide 0.035 by 4 to get 0.00875. Add 1 to that, and it becomes 1.00875. Raise that to the 12th power. Keep that in the calculator, multiply by 1500, and we get $1,665.31. Number 2, same thing. We're finding A. We're given P is 2400. R, this time given as a percent, 7.5%. T is 5 years and N is 12. The first thing we have to do is change our rate that's given as a percentage to a decimal. 7.5% is 7.5%. Move the decimal 2 places to the left, and we get 0.075. Plug in the values that we have. So 2400 for P, 0.075 for R, 12 for N in both places, and 5 for T. Our first step, multiply the exponents together. 12 times 5 gives us 60. Then we have to divide 0.075 by 12. That gives us 0.00625. Add 1 to that. That gives us 1.00625. Raise to the 60th power. Leave that in the calculator. Multiply it by 2400. And we get $3,487.91 after rounding. Number 3, same thing. We're given P as 123,000, R as 4.75%, T is 8 years, and our N this time is 360. We're asked to find A. First thing we have to do is change that percentage to a decimal for R. So 4.75% becomes 0.0475. Plug that in for R, plug 360 in for N in both places, plug 8 in for T, and plug 123,000 in for P. First thing we have to do is multiply the exponent. 360 times 8 gives us an exponent of 2,880. We then have to divide 0.0475 by 360, which gives us this nice long number. There's a bunch of 4s. Keep a bunch of 4s. The more 4s, the better. The more accurate your answer is going to be. Add 1 to that. Keep it in the calculator. Raise it to the 2,880th power. Keep that in the calculator. Multiply by 123,000, and we get $179,856.50. Number 4, surprise, surprise, same thing. We're given P is 750. R is 1.75%. T is 2 years, and N is 52. First thing we have to do for R, change that percentage to a decimal. So 1.75% becomes 0.0175. Plug that in for R. Plug 52 in for N in both places. Plug 2 in for T. Plug 750 in for P. What do? First thing, multiply the exponent. 52 times 2 is 104. Divide 0.0175 by 52. You get this nice long number. Keep as much of the places after the decimal point as you can. Keep it in the calculator. Add 1 to it. Keep it in the calculator. Raise it to the 104th power. Keep it in the calculator. Multiply by 750. And when we round to the nearest cent, our answer is $776.71. Number 5, same thing. This is just practice in cranking out these formulas. P is 5,000. R is 2.15%. T is 4 years. And N is 1. First step. Rate is given as a percentage. Change it to a decimal. 2.15% becomes 0.0215. Plug that in for R. Plug 1 in for N in both places. Plug 4 in for T. Plug 5,000 in for P. Start with the exponent. 1 times 4 is just 4. Then our division. 0.0215 divided by 1 is just 0.0215. Add 1 to that and you get 1.0215. Raise that to the 4th power. Leave that in the calculator. Multiply by 5,000 and you get $5,444.07 after rounding to the nearest cent. With number 6, we're changing up what we're looking for. In the first 5, we were looking for A. Now here in number 6, we're looking for P. We're given A is 75,000. R is already a decimal, 0.03. T is 5 years. And N is 360. Plug in what we know. That's going to fill in everything except for P. First step, multiply the exponent. 360 times 5 gives us 1,800. Then go to the division. 0.03 divided by 360 is this nice long decimal that ends up with a bunch of 3s repeating. Keep as many of those 3s as you can. Add 1 to that. Keep it in the calculator. Raise it to the 1,800th power. And you get 1.161826981690345, probably some more digits. Keep as many as you can. Either write that down or store the value in your calculator. Because our next step is to divide both sides by that number to get P by itself. 75,000 divided by that string, rounded to the nearest cent, is $64,553.50. Again with number 7. This time our R is given as a percentage again. So that 4% must become a decimal of 0.04. Plug in everything we know. So A is 12,000. R is 0.04. N in both places is 4. And T is 10. First step, multiply that exponent. 4 times 10 gives us 40. Do our division. 0.04 divided by 4 is 0.01. Add 1 to that, and you get 1.01. Raise that to the 40th power, and you get 1.4888637335882, and probably some more digits. Keep as much as you can. Either write it down or store it in the calculator, because our next step is to divide both sides by that string. 12,000 divided by that is $8,059.84 after rounding to the nearest cent. Number 8, same thing. Take our rate of 2.25%, change that to a decimal, 0.0225. Plug that in for R. Plug 12 in for N in both places. Plug 7 in for T. Plug 3,500 in for A. What do we do first? The exponent. 12 times 7 is 84. Go to our division. 0.0225 divided by 12 gives us 0.001875. Keep that in the calculator and add 1 to it. Keep that in the calculator and raise it to the 84th power. And you get this string, 1.170408142895986. Keep as much of that as you can. Either write it down or store it in the calculator, because the next step is to divide both sides by that string. 3,500 divided by that gives us $2,990.41 after rounding to the nearest cent. I apologize if this seems repetitive. That's because it is. The hardest thing about these problems is the order that you put them into the calculator. But this is repetitive practice in that, so that you can calculate these things correctly. Number 9. Same thing, except this time our rate has a fraction in it, given as a percentage. 3.5% is 3.5%. As a decimal, that's 0.035. Plug that in for R. Plug 1 in for N in both places. Plug 3 in for T. Plug 10,000 in for A. We're looking for P. First stop is the exponent. 1 times 3 is 3. Then our division. 0.035 divided by 1 is just 0.035. Add 1 to that, 1.035. Keep that in the calculator, raise it to the 3rd power, and you get 1.108717875 and some more digits. Keep as many of those as you can. Either write it down or store it in the calculator, because our next step is to divide both sides by that string to get P by itself. 10,000 divided by that string is $9,019.43 after rounding to the nearest cent. And number 10. Nothing new here. 4.4% as a decimal becomes 0.044. Plug that in for R. Plug 52 in for N in both places. Plug 1 in for T. Plug 850 in for A. We are solving for P. First stop exponent, 52 times 1 is 52. Then our division, 0.044 divided by 52 is this nice long number. Keep it in the calculator. Add 1 to that. Keep it in the calculator. Raise that to the 52nd power. And you get 1.044962913 and some more digits. Keep as many as you can. Either write it down or store it in the calculator. The next step is dividing both sides by that string to get P by itself. 850 divided by that string gives us $813.43 after rounding to the nearest cent. Number 11. We're told to use the compound interest formula with n equals 1 to model inflation. We're going to assume that the annual inflation rate is constantly 2.15%, and we're going to round our response to the nearest whole dollar. Number 11. In 2015, the median annual salary for a journalist was $37,720. Assuming that salaries have kept pace with inflation, how much would you expect a journalist to earn in 2018? So A is the future value. That's the most recent. That's the most forward in time. That would be the 2018 salary, which is what we're looking for. P would be the past value, the earliest in time. That would be the 2015 value of $37,720. R is 2.15% as decimal. That's 0.0215. N is 1 because inflation problems are annual, compounded annually. T, we have to do a little bit of work for. 2018 minus 2015 is 3, so T is 3 years. We use our formula, and we plug in these values. We have everything except A. So just like we did in the first 5, we crank out this formula. Plug in 37,720 for P, plug in 0.0215 for R, 1 for N in both places, 3 for T. And what do we do first? We do the exponent. 1 times 3 is 3. Then what do? We do the division. 0.0215 divided by 1 is just 0.0215. Add 1 to that. We get 1.0215. Raise that to the 3rd power. Keep it in the calculator. Multiply by 37,720 and then rounded to the nearest whole dollar. Our answer is $40,206. So assuming that salaries have kept pace with inflation, the journalist is earning just shy of $3,000 more, about $2,500 more per year. Number 12 is another inflation problem with the same directions. In 12, we're asked what salary would a nurse need to earn in 2019 to have the same purchasing power as a registered nurse who earned $42,000 in 1999. So A, the future value, the most forward of the values, would be the 2019 value. And that is what we're looking for. P is our past value, the most early value we have. That would be the 1999 value of 42,000. R, just as in the last one, is 2.15%. As a decimal, that's 0.0215. Inflation problems are annual interest compounded annually, so N is 1. And T, we need to do some work for. 2019 minus 1999 gives us 20 years. So plug in what we know. P is 42,000, R is 0.0215, N in both places is 1, T is 20. Take care of the exponent, 1 times 20 is 20. Take care of the division, 0.0215 divided by 1 is itself 0.0215. Add 1 to that, we get 1.0215. Raise that to the 20th power, keep it in the calculator, multiply by 42,000, and then rounded to the nearest whole dollar, we have $64,271. Number 13, again, we have an inflation problem. The situation in number 13, starting his career as a plumber, Ted currently earns around $49,000 a year. He is trying to compare his income to his father's, who started working as a plumber 23 years ago. How much would his father have needed to earn to have the same purchasing power Ted does today? So this time we have the most recent value. So the future value we use is 49,000. We have A. P, the past value, that's our unknown. R, as in all of these inflation problems, is 2.15%. As a decimal, that's 0.0215. N, as in all of these inflation problems, is 1, because inflation is annual interest compounded annually. And T is 23, because we're told there's a 23-year difference in these salaries. Plug in what we know. 49,000 for A, 0.0215 for R, 1 for N in both places, and 23 for T. We're solving for P. First thing to do is take care of the exponent. 1 times 23 is 23. Then take care of the division. 0.0215 divided by 1 is 0.0215. Add 1 to that. We get 1.0215. Keep that in the calculator. Raise it to the 23rd power. Keep it in the calculator. We get 1.631107303 and probably some more digits. Keep as many as you can, either in the calculator stored or write it down, because our next step is to divide both sides by that string to get P by itself. 49,000 divided by that string of digits, rounded to the nearest whole dollar, is $30,041. Number 14 is an inflation problem. In 2010, the price per carat of diamond was $24,500. What would you expect this price to be in 2019? So we're looking for the future value. We have the past value. P is 24,500. R is 2.15%. As a decimal, 0.0215. N is 1 because inflation is annual interest compounded annually. And to find T, we subtract these years. 2019 minus 2010 gives us a T of 9. Plug it in. Plug it in, plug it in, plug it in. Just like those Glade commercials. So P is 24,500. R is 0.0215. N is 1 in both places. T is 9. Take care of the exponent first. 1 times 9 is 9. Then do our division. 0.215 divided by 1 is, 0.0215 divided by 1 is 0.0215. Add 1 to that. We get 1.0215. Keep that in the calculator and raise it to the 9th power. Keep that in the calculator and multiply by 24,500. And you get $29,670 when we round to the nearest whole dollar. And our last inflation problem like this is number 15. Today, the average college student spends $1,200 per year on textbooks. If the price of textbooks had kept pace with inflation, how much would you have expected the average college student to spend on textbooks 30 years ago? So we're looking for the 30 years ago price. We're looking for the past value. We have the future value of 1,200. Our rate is 2.15%. Annual interest compounded annually. So R is a decimal is 0.0215 and N is 1. T is 30. That's given in the problem 30 years ago. Plug in everything that we have, and we're left with solving for P. Take care of the exponent first. 1 times 30 is 30. Take care of the division next. 0.0215 divided by 1 is 0.0215. Add 1 to that, 1.0215. Raise to the 30th power, and you get this string. Either store it in the calculator or write it down, because the next step is to divide both sides by that string. 1,200 divided by all that, rounded to the nearest whole dollar, is $634. Number 16. George purchased a 5-year CD for $2,000 at 4% annual interest compounded quarterly. How much will he receive when he redeems the CD? So we want to know how much he'll receive when he redeems it. That means we're looking for the future value. We have the past value of $2,000. 4% interest as a decimal is 0.04. Compounded quarterly means our N is 4. And it's a 5-year CD, so T is 5. Plug in everything we know into our formula. What do we do first? Take care of the exponent. That's correct. 4 times 5 is 20. What do we do next? The division. That is correct. 0.04 divided by 4 is 0.01. Keep that in the calculator and add 1 to it. You get 1.01. Keep that in the calculator and raise it to the 20th power. Keep the result in the calculator and multiply by 2,000. And you end up with, rounded to the nearest cent, $2,440.38. Number 17. Elaine purchased a 20-year CD at 6.7% annual interest, compounded daily for $800. What will the CD be worth when it matures? We want to know the maturation value, the value in the future. So we want to know A. We have the past value of $800. 6.7% as a decimal is 0.067. Compounded daily means our N is 360 and T is 20. Plug in everything we know. What do we do first? We take care of the exponent. 360 times 20 is 7,200. Take care of the division. 0.067 divided by 360 gives you this long string. Keep it in the calculator. Add 1 to that. Keep it in the calculator. Raise it to the 7,200th power. Keep it in the calculator. Multiply by 800. Round to the nearest cent, you now have $3,054.85. Number 18. Ellen purchased a 10-year CD at 5.25% annual interest compounded monthly for $7,500. How much interest will she earn over the lifetime of the CD? So we're not looking for the future value. We're looking for the amount of interest. The future value is going to be the principal plus the interest. So we need to find the future value in order to find the interest. So even though it doesn't answer the question, we still need to find the future value first. The past value is 7,500. The rate of 5.25% as a decimal is 0.0525. Since it's compounded monthly, our N is 12. And since it's a 10-year CD, our T is 10. Plug in what we know into the compound interest formula. Take care of the exponent first. 12 times 10 is 120. 0.0525 divided by 12 is 0.004375. Add 1 to that, 1.004375. Raise to the 120th power. Keep that in the calculator. Multiply by 7,500. You get $12,663.93. That's the future value. That's A. A equals principal plus interest. A equals P plus I. So $12,663.93 equals 7,500 plus I. Subtract 7,500 from both sides, and we get that I, the amount of interest earned over the lifetime of the CD, is $5,163.93. Number 19. David wants to open an investment account today that will pay for his newborn granddaughter's college education. He assumes that he will need $95,000 18 years from now. If he can get an investment that earns 6.5% annual interest compounded weekly, how much does David need to invest in the account today? So we have the future value, 95,000. We're looking for the past value. 6.5% as a decimal is 0.065. N is 52 because it's compounded weekly. T is 18. So, plugging in everything we know into the compound interest formula leaves us with a missing P that we are going to solve for. Take care of the exponent first. 52 times 18 is 936. Take care of the division second. 0.065 divided by 52 gives us 0.00125. Keep that in the calculator. Now add 1 to it. You get 1.00125. Keep that in the calculator. Raise it to the 936th power, and you get 3.2196393777773, and so on and so forth. Either store that value in the calculator or write it down with as many spaces after the decimal point as possible. The next step is to solve for P by dividing both sides by that string. 95,000 divided by that string of numbers gives us, rounded to the nearest cent, $29,506.41. Number 20. After 12 years at 3.5% annual interest compounded quarterly, Kira's CD is now worth $1,200. How much interest did Kira earn over the lifetime of the CD? We are looking for I, which is not a part of the compound interest formula. But if we find A and P, we can solve for I, since A equals P plus I. We have A. We can solve for P. R is going to be 0.035. That's 3.5% as a decimal. We're compounding quarterly, so N is 4. And it says 12 years in the problem, so T is 12. Plug in what we know. We're able to solve for P. Take care of the exponent first. 4 times 12 is 48. Take care of the division next. 0.035 divided by 4 is 0.00875. Add 1 to that. Keep it in the calculator. Raise it to the 48th power, and you get this nice long string of numbers. Either store that in the calculator or write it down, because the next step is to divide both sides by that string to get P by itself. And 1,200 divided by that string of numbers, rounded to the nearest cent, is $789.90. So that's P. We know A equals P plus I. So A is 1,200. P is 789.90. We subtract 789.90 from both sides to get I by itself. And 1,200 minus $789.90 leaves us with I, the interest earned, $410.10. Number 21. Taylor's salary this year was $47,000. Assuming 2.15% annual inflation, what would Taylor's salary need to be in 3 years in order for her to have the same purchasing power? So Taylor's salary this year, the earliest value we have in the problem, is 47,000. That's P. That's the past value. The future value is unknown. That'll be the salary 3 years from now. This is an inflation problem. So 2.15% is 0.0215. Annual interest compounded annually, N is 1. And we are looking at 3 years in the future, T is 3. Plug in what we know. Take care of the exponents first. 1 times 3 is 3. Take care of the division next. 0.0215 divided by 1 is 0.0215. Add 1 to that. Keep it in the calculator. Raise it to the third power. Keep it in the calculator. Multiply by 47,000, and then rounded to the nearest cent, we get $50,097.14. And finally, number 22. In 2017, James Sawyer purchased a 3-bedroom home for his family for $215,000. Assuming an annual inflation rate of 2.3%, what would a similarly sized home have been worth in 1992 when his father Thomas purchased the home James grew up in? So this time we have the future value, $215,000. We're looking for the past value in 1992. 2017 minus 1992 is 25 years, so T is 25. Inflation is annual interest compounded annually, so N is 1. And this time we're told that our inflation rate is 2.3%. So this is different from the previous ones. 0.023 is the inflation rate. Plug in what we know. That leaves us with a P to solve for. Take care of the exponent first. 1 times 25 is 25. Take care of the division next. 0.023 divided by 1 is 0.023. Add 1 to that. Keep it in the calculator. Raise it to the 25th power. Keep that in the calculator as a stored value or write it down. You get this string. Why are we keeping track of this? Because the next step is to divide both sides by it, not divide the value by. So we have 215,000 divided by that string and rounded to the nearest cent. We get $121,772.05. And that's the homework for section 3.3. And that's the end of Unit 3.